Alright, create this tutorial for conceptual understanding of Hydra, and so that we can understand what's going on. I'm doing these concept tutorials so that people can have a better understanding of the commands they're typing, because just typing commands without having any real understanding of what's going on, that's a good way to get in trouble, for one. For two, you can't repair the problem because you don't really know what's going on. Having a good understanding of actually what's going on, I feel, will help to increase my own understanding. For one, is conceptualizing it, visualizing it, seeing it. And the other thing is troubleshooting. If you ever run into any problems, it's always good to be able to kind of think on the fly. I mean, you got some practice, try some stuff, because you know what's going on. So Hydra is a really simple, straightforward. This is going to be probably a really quick tutorial. It's pretty straightforward. You have a thing on your network called a router. Now, if you have something, a lot of people do, you have a router with Wi-Fi. Now, what Hydra does, the main purpose of Hydra is to crack or guess the password on that router. But the router has a little added security, which is a username. So the router has a username and a password. Now, this username and password is different from the BSS, well, hopefully it is, I mean, regularly it is, BSS ID and the Wi-Fi password. It has nothing to do with the Wi-Fi password or the encryption type. Those are separate things. So what would happen is this router would possibly be connected to a switch. Doesn't have to be. It could be directly connected to nodes. Basically, you have your network down here, your nodes, your computers, your devices, your little phone. Well, I guess you don't connect your phone there. At least I have it. Yeah, if I could, it'd be all right. And then, like, you have your phones connected off the Wi-Fi or whatever. That's a happy face and hair, because it's a cool phone. So this is what Hydra is going for. Whatever it takes to get onto this network, whether you walk up and plug your happy hacking ass onto the network directly, or if you jump in through the Wi-Fi. Because computers jump when they get onto Wi-Fi. It's not like connecting. Anyway, once you're on the network, this is connected to the internet. I mean, it doesn't have to be connected to the internet, but most times it's connected to, well, routers connect to internets or other routers, whatever. Once you're actually on the network, this is what's called the default gateway. On the majority of networks, it's not always the default gateway. Your default gateway could be a proxy connected to the router, so it would have to hop. But either way, if you did a trace route or trace route, if you ran a trace and seen the hops that you had, you could basically see when the network changed from internal addressing to external addressing. So what you're looking for is the last hop before that happened, and that would be your router, your default gateway. Because, you know, if you don't know what's going on, your default gateway is not always a router. Since this is the default gateway, and let's just say we found the default gateway through hopping or whatever, this thing has an IP address. Actually, it has two IP addresses. It has an IP address for this line right here, where this interface, which would be, let's say, 207.22. No, that's okay, but .4.3 or whatever, you know. And then it has its interface for the inside network, which would be 192.168.0.1, depending on what network it's on, you know, whatever. But you can, if you study a little bit about IP addresses, you can tell the difference between internal and external. I mean, it's you can't always tell. I mean, but it's intuitively you can. So once you have this address 192.168.0.1 as your default gateway, all of these computers in here would be somewhere inside /44. All of these networks would be 0, 2, 0, 3, 4, 5, 6, and here's your happy hacker number 18. For some reason, the DHCP decided to give him 18. So what you're doing with Hydra is that IP address. Let's just say IP. Addy. The router has some way of connecting to it, and with Hydra, you're using the HTTP protocol, basically the web page of the router. Let me check to see if I'm recording. Looks like it. Okay. You're using the small web server that's on this router that, you know, people use to configure their stuff with. I know the home Cisco routers, like the Linksys 4200. I mean, different Cisco routers. Home ones, I know they have a web port that they use. However, the Cisco 4000, I don't believe that has a web interface. I know it has other ports, and I'm not sure if Hydra supports the other protocols. But in this instance, we have found the IP address of the router, so we're going to open up a browser. We're going to open up a browser and type in your little address bar, because address bars are little, the IP address, 192.168.0.1. Now, usually what happens if you've ever programmed your own router is you get this dialog box. Username and password. In order to configure that router, you're going to have to type those in order to start to set stuff. Hydra will actually, on the happy ass hacker's computer, will use a password list and a username list. Now, given enough time and given enough space, this person could have an enormous amount of usernames and passwords. And what Hydra allows you to do is take those two username and password lists, those two lists, and run them or try them on this router in every possible every possible combination that there is. So a password list already has all of the possible combinations of characters, numbers, capitals, lowercase letters. So given a big enough list, that is hackable. I haven't seen on my routers, or I've just never said it, but it's a good idea. Password attempts. Actually, the Cisco routers, that the industrial ones, like the 4000, that actually does have that option. If someone does a bad password, it'll actually just lock that. It'll lock the machine till someone actually rollovers into it, uses a rollover cable or something like that. Yeah, it has to be administratively. I believe you have to plug directly into it once that happens. Home routers, they may have that option. I just don't remember ever checking it or even looking for it. But it is a good idea because you know, we'll talk about what happens after someone gets in. But so while this is running, it's testing every combination possible. Given enough time, like I said, it's going to get cracked. So that's the basic premise of what's going on. Once you have this username and password cracked, now you have access to the configuration of this router, of this machine on this network. Now let's look at the risks, the rewards, and the remedies. We call them the 3 R's, Wayne.
Reading, writing, arithmetic.
We used to call them the 3 W's, but then people got confused.
Because I only got 2 W's. That's why they was getting confused.
Yeah, that's true. They were thinking of you, and yeah. Okay, risk. Let's put Hydra back up here so we still know what we're talking about, so I don't lose anybody. Yeah, risk. Reward. Reward. And then resolution. And I forgot to mention something in that little picture that I had, so I'll do it really quick. On your router, you don't always have to be on the internal network. Like, let's say this is internal and this is external. Some people, like, and this is the internet. Actually, you can connect to the web interface of a router that you are not physically, or I mean, you're not locally connected to. There's options that people can set on the router that will allow you to connect from outside. I believe on most of the routers that I've messed with, the home routers, I believe the option is set to off when you by default. So this exploit can be ran remotely, and if you were just searching for, like if you had a script or something like that, I mean, it wouldn't be that hard to just any 80 port you see, if it pops up a dialog, if you get a username and password dialog, then you might, then you can check to see if it's really a router. But if you're targeting someone and it's not on by default, then go through the Wi-Fi, or maybe there's an actual buffer overflow, or maybe there's an exploit for that specific router. So let's look at the risks. The risks are, if you are on the network, there is the possibility that someone will know you're on the network. You got a wire dragged into 100 feet to your neighbor's house, plugged directly into their window. Not like this cord at all. Spool's only $30, and some crimps $5. Looking at them follow the the wire out their window is priceless. but there is that and the Wi-Fi range ain't so great unless you had like some repeater. You had plugged in a repeater in some abandoned house next to theirs, and then you're a little bit farther away. But I mean, usually you can pick up on Wi-Fi kind of far away, but there is that locality thing. You know, people can pinpoint Wi-Fi's and stuff like that. So if you're on the network, there's always the possible physical interaction. Let's see. The other risk is this. Pretty much anytime you're on someone's network, I've said it before. If you're not patched, you know, and they hack you, then you know, oh well. Let's see. The other risk is that you're trying to brute force their router. What did I put there? Oh, being hacked. You're trying to brute force their router, so you know, if you haven't changed your Mac, and I mean, there are other things people can detect for. I'm not totally spiffy on you know, CPU, basically fingerprints and stuff like that. I'm not totally sure if there's like new routers that are doing that, but you know, if you don't have your Mac, you know, if you're using a throwaway, that's different. But at the same time, you know, the router will log your Mac. Let's see, your MAC address. Oh, it's shutting down on you. Like the thing with the higher up routers, the higher Cisco routers and stuff like that. They will shut down. They will shut down that interface, and the administrator will be alerted. And if they're any kind of administrator, it's going straight to their phone. And if you're on, like I said, if you're on the Wi-Fi, there's always that chance of physical interaction. You know, as soon as someone sees, okay, bam, you know, someone just tried and my interface shut down. You know, let's look around a little bit. Also, if they do have the attempt thing enabled, then you know that's a bust. As far as you know, you're done. You know, that goes with shutting down stop attempts. I just classified them different because, you know, one's a little bit more of a risk than the other. Yeah, let me see. One's more of a risk than the other. Here you go.
Thank you.
Yeah, I'm kind of handy. It is a man's tool. Let's see. Yeah, I don't touch it. I don't do any manual labor. Let's see. Stop attempts. Logging. Alright, we'll keep moving, and then if I come up with something else. The rewards. You do have access to their router. Their router, unless they have redundant networking and stuff like that, you do have control of their single access point. Control of access point. With this, you can change the BSS ID, you know, to something cool like happy ass hacker. That's always a plus. Let's see. Like you can change all of the settings. Let's see, what are the rewards of changing the settings? You can install firmware. You can install firmware on their router, because their router has an operating system. Actually, it's called an iOS something system, operating system, in-out system maybe, an iOS. Anyway, they have an operating system. If you install a custom firmware that'll fit on their router, basically you can turn their router into a small proxy. You now have a proxy that you can jump to and hide your own ass. Any attack that you do will be believed that it's coming from their router. Since you do have their password, I guess that's not really a reward. You can guess their other passwords. Their other passwords are probably the same. I guess that is a small reward. You know what some of the nodes on the network may be using as a password. Let's see. I don't know if you can port forward outside of the network. I don't know if you can automatically do that. I've never tried to do that. I've never tried to actually port forward outside the network. But it does have a spot for an IP address, so I mean, if anybody wants to comment on that, port forwarding outside the network. Inside the network, port forwarding actually would be pretty handy, because if there's any services running on any of the networks for internal use only, then all of a sudden there's a gateway straight to one of those services that was never intended to be an outside service. Let's say the network was running an internal web page, like an intranet web page for the actual workers to share data and work together and stuff like that. SMB, like shares, network shares, they're running that. Now all of a sudden they're sharing with the whole globe that knows their router's IP address. So pretty much you can port forward anything you want, so you don't have to be there on their Wi-Fi close anymore. One of the other risks is the log, not just the MAC logging, but it does log your host name too. But I mean, that's easily changeable. But if you're using your first and last name as your host name, or some kind of variation, and it's still there and you don't delete it, I mean, it's just one more tack. It's one more time you have to tell Bubba no. Let's see, the resolutions. Definitely set password attempt limit. And if you're using a good machine, do a shutdown on your router if anybody guesses the wrong password more than 3 times. Disable outside activity thingy-majig, to where your router doesn't respond. I think on the home ones, I think it's called stealth mode. Don't let your router talk to people. There's no reason. If you're on the internet, it knows where to come back. Disable or enable. Disable outside. Just disable outside. There you go. Stealth mode. Be aware. Check your router every once in a while and see where your port forwardings are. Awareness. I mean, I log into my router pretty much regularly. Anytime you're dealing with a router, you want to use MAC filtering. You want to use MAC filtering so that any machines that you have on the network, you know, your router knows that those are the only machines. I mean, that's not such a hard thing to do with to spoof with MAC spoofing. MAC spoofing technology has gotten real good, but that's just an added thing that the person has to do is copy and paste your MAC address once they see it. Hide your BSSID. I mean, we're talking about routers right here. Hide your BSSD. Not that nobody can see your BSSD, but it is just a little bit more of a pain in the ass. And my basic philosophy is that anything connected to anything can be hacked. But with so many things being connected, you don't want to be the easiest to be hacked, because if someone's just walking by and there's $50 on the floor versus $50 being in a mailbox with a lock on it, I mean, granted, you can bust open the lock, but why not just take the $50 on the floor? I mean, you could get both if you want, but I mean, it's easier to take the $50 and keep pushing. So you find another $50 because it's laying everywhere. Let's see. I know there's got to be more rewards. I think probably the best one is firmware. Allowing the person to use their own router for some things while you use it for what you want as well. So, I mean, there's protocols that deal with domain controlling, I believe. Basically, like, once you log into the network or the router, you're still not a part of the network, because just because you're on the network doesn't mean that you're a part of the network. So domain controllers, in Windows, I don't think Windows has domain controllers for anything except for Windows Server. And if you don't feel like downloading such a big package and you don't feel like paying, there's solutions for Unix and Linux. I say BSD's Unix, but that's just because I'm hopeful. Let's see. I'm not totally sure what the domain controllers are for Unix, because I keep thinking Samba. However, yeah, I'm not totally sure about that. I'll look it up. Or if someone wants to comment on that. But that's just the basic premise of what's going on. I mean, why you're doing it. I mean, if you're just out there just hacking random shit just because you found a program, you know, I mean, good luck. But these are the reasons that someone would hack. And I mean, once you have that firmware, you can launch attacks on other things, so you're covering your own ass. And you do want to have your own router secured, because people can do stuff like this, run proxies and stuff like that. And I mean, one of the other rewards is that you can change their DNS. That's a really good one. You can change their DNS server so that anytime these people access the internet, it's going to go to one of your pay-per-click websites and get you a cent. And you can basically control traffic. Actually, that was a pretty good exploit I seen on the DNS. I mean, I had to do some serious. Anyway, yeah, having their DNS change is awesome. Because you get the idea. If their DNS is changed, basically, you can spoof some websites and get any information you want. Info, Facebook, Twitter, cloud, VPNs, just basically anything. You know, you can escalate your privileges by pretending to be someone else through the DNS. You get info, and then you can go back into the machines. But if you don't have a goal in mind, you know, I mean, there you go. Hope you enjoyed it. These tutorials are for EternalLLC.com. See you around.